So we start with this express 2x square minus 8x plus 11 in this form. We can do it with comparing coefficient methods or, directly by taking common. That's totally up to you. So this is 2x square minus 8x plus 14. That can be written as 2 into x minus a whole square plus b, right? Okay. Now it is recommended that we use comparing coefficient methods. So if I open it on the right hand side, that would be x square minus 2ax plus a square plus b, right? That would be 2x square minus 4ax plus 2a square plus 2b, right? On left hand side, we have 2x square negative 8x plus 14. And now we are simply going to, compare coefficients left hand side and right hand side. Okay.
Okay.
So I think we don't need to compare for x squared. So let's compare it for x. Now on left hand side, it is negative 8 for x. And on right hand side, that is equal to negative 4a. Now you can say value of a is 2, right? Similarly, we can compare the constant. Now for constant, this is 14 and this is 2a square plus 2b, okay? Giving us 14 is equal to 2 into 2 square plus 2b. So 14 is equal to 8 plus 2b. That would be 14 minus 8 is equal to 2b. That is equal to 6 is equal to 2b. So value of b we get is 3. So we can write it in this form, that is 2 bracket x minus a whole square plus 3.
What is the answer?
That is the answer. Is that clear?
Yes.
Okay. Is it clear?
Yes.
Now let's move to next part. Okay, that's also exactly the same. Let's try this one out. So now we have 4x squared minus 24x plus b. That can be written as a into x plus b whole square plus c. Okay. Now let's try it using, the other method. So you can take 4 common from here. Left hand side, that would be 4. X square minus 6x. And you can keep p outside the bracket, okay? Where a, b, and c constant to be given in terms of p. A and b are integers and c is to be given in terms of p. So we take 4 common, and if now we use completing square method, so that has to be 4 bracket, that is going to be x minus 3 whole square minus 3 square plus p, right? We have learned this method. X square plus 2 dx would give us x minus d whole square, okay? So that is 4 into x minus 3 square minus 9 plus p, right? And then we have to multiply 4 inside the bracket and simplify it. That would be 4x minus 3 whole square minus 4 nines are 36. And this is plus b. Now, if you see, this can be expressed in this form, that is a into x plus b whole square plus c. Now you can clearly see that value of a we get is 4, right?
Yes.
Value of a is 4 and value of b is negative 3.
Yes.
And value of c, the constant thing that's coming outside this, is p minus 36, right? Or minus 36 plus p, it's up to you, whatever you want to write. So this was 4. Yes. Here it is a. This is x minus p, that's b is minus 3. And we have p minus 36 as
C.
C. So C is equal to P minus 36. In the question, they have asked us to find out the value of C being in terms of P. So this is how we do it. Done, beta? Any question? And
No.
okay, that's good. And now we have the next part of the same question that states hence or otherwise. Okay, remember the questions in which they say hence or otherwise, you have open option. So either you could use this result that you just calculated, or otherwise find the set of values of P for which the equation has no real roots. Okay. If you remember the thing that we just learned in quadratics, that if this equation has no real roots, then this must lie always above the x-axis. Okay. If this is your x-axis, and if this line has to have no real roots, right? So for no real roots, no real roots, we would say, if you claim that this has no real roots, then this must be lying above the x-axis. Okay. And for that, this C value must always be greater than 0. So in actual curve, if you see this one, x is equal to 3. So this is your line of symmetry. X is equal to 3. And coordinates of vertex were 3 and p minus 36. Right? So if we claim that this quadratic curve has no real roots or no solution, then it must be always lying above the x-axis. So p minus 36 must be greater than 0.
Yes.
The y coordinate of vertex. Okay? Is it clear? Yes. Okay. So then it is going to be p is greater than 36. So that is the set of values of p for which this is greater than 0.
Zero.
I hope it's clear, right?
Yes.
Okay. Now this is the same question. Okay. You can skip it. And hence it is given that the equation case of constant exactly one root. Let's do this for the quadratic. Now, if we claim that this, what do you say it? The curve has only one root, that means this is the case of repeated roots. So in repeated roots, we used to say that this would be the scenario. Okay. So it is given that this equation where k is a constant has exactly one root. Find the value of this root. So that is 16x squared minus 24x plus 10 minus k is equal to 0. Now this is your c value, right? This is your a value. This is your b value. This is your c value. Calculator, mobile. So now we have for tangent b square minus 4ac must be equal to 0. So that is equal to minus bb square minus 4 into a into c must be equal to 0. So we have 24 square is 576 minus 16 fours are 64. That would be 640 plus 64k must be equal to 0. Now 576 minus 640 would be equal to negative 64 plus 64k is equal to 0, right? Giving us 64k is equal to 64 and giving us k as 1. Okay? So this is how we are going to use the discriminant stuff for finding the number of.
Minus K.
Sorry?
Minus K.
No, value of k would be 1.
Yes.
10 minus k is, this is the c value, na? So we have b square minus 4ac. So this is b square, 24 square minus 4, a is 16, and this whole thing is c. तो वो हमने माइनस माइनस प्लस कर दिया यहाँ पे. ठीक है? That gives us k is equal to 1. I hope it's clear, right?
Yes.
Okay, good. Next is, okay, functions. We're going to start functions after this. That's the same thing for completing square. Yes, for no real roots. When they claim that this find the set of values of k for which this equation has no real roots. And can you tell me how it's gonna work? For no real roots would mean that my quadratic curve is not intersecting the x-axis, right?
Yeah.
And in case of discriminant, it has to be b square minus 4ac is less than 0. So let's do it. That is 8x square
This carries is true.
plus kx plus 2 is equal to 0. Now this is your A, this is your B, this is C. So that has to be b square minus 4ac is less than 0 for being not having no real roots. Okay, so that is k square minus 482. That has to be less than 0. So that is equal to k square minus 64, that is less than 0. So that is k square minus 8 square less than 0. You need to be a bit careful while solving such questions, okay? K plus 8 and k minus 8 is less than 0. Now, since this is again a quadratic, right? And if we see the structure of quadratic, it goes like this. And if coefficient of x square or k square is positive, that means it is a concave up or a smiley face. Okay. So now this has to be less than 0. You know, this would be the portion where this is less than 0. So we need to find these 2 points and we would say this is my answer. So k, and for that, we use the equation. Instead of inequality, k plus 8 is equal to 0 and k minus 8 is equal to 0. That gives us k is equal to 8 and k is equal to negative 8. So that is going to be minus 8 and that is going to be plus 8. Now, these are set of values of k for which this curve is lying below the x-axis.
That is the answer.
Yeah, so this is the answer when we have no real roots. So at the end, you would write for these values of k, curve will have no real roots. No real roots. Done? I hope it's clear. That's the thing we've been doing repeatedly, right? Is that clear, Beta? Ayan?
Yes.
Okay. And then again, we can express it in this format, hence solve this equation. Okay. Showing the coordinates of the stationary point, you're not required to indicate the curve. Okay. When we talk about stationary points, in future we'll be doing differentiation. ठीक है वो भी कर लेंगे, but for now they are basically asking for once you write it in this complete square form now, that simply gives you the thing. So let's do it first. 4x square plus 20x plus 6, that can be written as a into x plus b whole square plus c, right? So let's do it with common stuff. That is x square plus 5x and plus 6, right? So 4, that would be x plus 5 by 2 whole square minus 5 by 2 whole square plus 6, that would be 4 into x plus 5 by 2 whole square minus 25 by 4 plus 6. Now we can multiply this 4 inside the bracket, giving us 4 into x plus 5 by 2 square minus. You can cancel this 4, so this 4 with this, so that would be only 25, right? And then plus 6. So 4 into x plus 5 by 2 whole square minus 19, right? So 4x plus 5 by 2 minus 19 whole square. That's it. So if we are asked to, sketch the graph, this is how it works. So that has to be passing through 6. So that is it, right? And your line of symmetry, we can substitute this equal to 0, giving us minus 5 by 2, right? So that is equal to x is equal to minus 5 by 2. And minus 19, and this is suppose this is minus 19. So your curve goes like this. Okay. So the vertex is minus 5 by 2 and minus 19, right? And this is how we have to sketch it. So at the end, when this is sketch the graph showing the coordinates of the stationary point, you are not required to indicate where the curve crosses x-axis and y-axis. So they are least bothered about the intercept. So you just draw the line of symmetry, that is this is 0. X is equal to minus 5 by 2, right? And you can sketch the graph showing the turning point only. That means this is minus 5 by 2 and minus 19. Okay. So when you will be studying differentiation, in differentiation, we'll be doing the stationary point and all that. So where dy by dx would become equal to 0. So we would differentiate it and we'll put it equal to 0. Simply. Is that clear?
Yes.
Okay. Now the next is, okay, next is this would be of 3 marks, and they have clearly mentioned that you're not required to indicate where it crosses the x-axis, right? You can solve this thing as well, so that's pretty easy. Yes, we have learned equations reducible to quadratic equation. And could you tell me how you're going to approach this question, beta?
Use
You remember when
substitution.
it
Let
was,
y
yeah,
let third y be equal to
root
u.
e or p or anything. Yeah. So under root y equals to t, that would be 6t plus 2 divided by t minus 7 is equal to 0, right? It's going to be this equation, and now we can surely solve it. Taking LCM would give us, sorry, taking LCM, that would be 6t plus 2 divided by t is equal to 7. That would be t, that is 6t squared plus 2. And you can cross multiply it, making it 6t squared plus 2 is equal to 70, right? So that is going to be 6t squared minus 70 plus 2 is equal to 0. Now 6 2s are 12. What are the possible factors? I guess 4 and 3. So 6t squared minus 4t minus 3t plus 2 equals to 0. So what we can do is 2t, we can take 2t common. That would be 3t minus 2 and minus 1. That would be 3t minus 2 is equal to 0. That would be 3t minus 2 into 2t minus 1 is equal to 0, right? Giving us 3t minus 2 is equal to 0 and 2t equals to 1. I've skipped one step. 2t minus 1 equals to 0, and then t is equal to 1 by 2, and t is equal to 2 divided by 3, and t is equal to 1 divided by 2, right? Then you go back and see what have you substituted, or suppose that was under root y equals to t. So under root y is equal to t. Under root y is equal to 1 by 2. Now we're going to take squares on both sides to cancel this. So y would be 4 by 9 and y would be 1 divided by 4. These are two possible answers that we can have. Done? So this was an example of solving equations that are reducible to quadratic. Okay. Is that clear?
Yes.
Good. Next question is going to be, so this was equations reducible to quadratic, right? Exactly same question. Let's do it quickly. That what we are going to do. Acha, what was the thing that we are going to take the smaller power? So here it is x cube. So x cube is equal to t, and we take square on both sides. That would be t square. So that has to be 8t square plus 215t minus 27 is equal to 0. 215t minus 27 is equal to 0, right? So you can find the factors or you can directly use the quadratic formula. 27, 8, 160. Could you check what it is? No. You can use A, B, C for quadratic and you can solve it for. So x is equal to negative b plus minus under root b square minus 4ac divided by 2a. That was 216. I guess 216 and 1 can be done. 216 and 1, right? Plus 216 and minus 1 be the factors. So that would be easy for you instead of doing this. So let's do it with that manner. So 8t square plus 216t minus 1t minus 27 is equal to 0. So we can take 8t common, making it t plus 27 and minus 1t plus 27 is equal to 0. So that would be 8t minus 1 and t plus 27 is equal to 0, giving us 8t is equal to 1 and t is equal to negative 27. T is equal to 1 by 8 and t is equal to minus 27. Now, if we see, we have substituted t as x cubed. So that is going to be x cubed is equal to 1 by 8. X cubed is equal to minus 27, right? We take cube root. So that is 1 divided by 2, I guess. And that is going to be negative 3. 3 is a 9, 3 is a 27. So these are the answers that we have. Okay? Done? Is that clear?
Yes.
Okay. Area under the curve, we would be doing it in integration, but for now we need to find, I guess, coordinates of B and C. So we have a simultaneous equation, linear, and the other one is this. So y equals 3 minus x, right? Yes. And the second one is y equals to 4x 1 by 2 minus 2x. So what we are simply going to do is we're going to substitute linear into quadratic, or this. We're going to replace y value with this. So that is 3 minus x is equal to 4x 1 by 2 minus 2x. So that would be 2x minus x minus 4x 1 by 2 plus 3 is equal to 0. That would be x minus 4x 1 by 2 plus 3 is equal to 0. That is again type of example, equations reducible to quadratic, right? So what we're going to do is we're going to suppose x power 1 by 2 is equal to t, and then x is going to be t square. So it is t square minus 4t plus 3 is equal to 0. That would be, sorry, it's going to be t square minus 3t minus 1t plus 3 is equal to 0, giving us t as t minus 3 minus 1, t minus 3 is equal to 0. So t minus 3 and t minus 1 is equal to 0, giving us t as 3 and t as 1, right? And then you come back to this actual substitution. T is x raised to the power 1 by 2, that is equal to 3, and t is x raised to the power 1 by 2, that is equal to 1, giving us, we take square on both sides, right? That is 9, and x is equal to 1, right? Now we have two answers for 9 and 1. So y was equal to 3 minus x. 3 minus x. X is 9, so y would be 3 minus 9, that is equal to negative 6. So it is 9 and negative 6 here. Y equals to 3 minus 1, that is equal to 2. So that is 1 and 2. So 9 and minus 6 would be definitely C, and 1 and 2 is going to be this one, right? Yes. So these are the points of intersection. I hope it's clear, Ayan. Any
Yes.
confusion related to this? Uh, अस्सलाम वालेकुम। अहमद ज्यादा देर से तो नहीं वेट कर रही? अहमद,
Yes, sir.
मुझे मैसेज कर दिया करो immediately whenever you join, because once I'm sharing this screen I can't see the uh, waiting room. Okay,
Okay, sir.
ठीक है। I'll be sharing this video on YouTube channel और link share कर दूंगा so that you could have a look. ठीक है, the things that you missed. So just a quick look what we did. We are simply revising this quadratics. We're doing past paper questions. Okay. I'll be sharing this document with you and I'll be sharing recording on YouTube. Okay. So just can have a look. By using our suitable substitution, that we again 2x minus t, we'll have to do substitution twice here. First 2x minus 3 as t. So that would be t square minus 4 divided by t square minus 3 is equal to 0. Okay. T square minus 4 by t square is equal to 3. T square, that would be 4, right? So that would be t square. T4 minus 4 is equal to 3. Cross multiplied. So it is T4 minus 4 is equal to 3t square, making it T4 minus 3t square minus 4 is equal to 0. Again, what do we have now? Equation that is reducible to quadratic, right? So now we can do let t square is equal to maybe y, right? So that has to be y square minus 3y minus 4 is equal to 0. So that would be y square minus 4y plus 1y minus 4 is equal to 0. So that would be y into y minus 4 plus 1, y minus 4 equals to 0. So y minus 4 and y plus 1 equals to 0. That gives us y equals to 4 and y equals to negative 1. But y was t square, so you go back and that is t square is equal to 4 and t square is equal to negative 1. We would discard this and we move forward with t square is 4. So now t square is equal to 4. We take square root on both sides. T would be plus minus and 2, right? So if this is plus minus and 2, this has to be t is equal to 2 and t is equal to negative 2. So t was 2x minus 3, that is equal to 2, and 2x minus 3, that is equal to minus 2, right? And now we can do 2x is equal to 3 plus 2, that is equal to 5. And 2x is equal to 3 minus 2, that is equal to 1. So that is 2x. X is equal to 1 divided by 2. Now, once we have x 5 by 2 and this by using a solution, these are possible answers to this question, right? I hope it's clear.
Yes.
Okay. अमित समझ आ गई बात बेटा? Yes. Yes.
Yes, sir.
I'll be sharing this later on, ठीक है? मैं आपको बाद में भेज दूंगा, ओके? बाकी हमने आई गेस से किए थे क्वेश्चंस कुछ कर लेते हैं भी इनमें से कोई Yes, a very important concept. Sometimes they would ask you that show for all values of m, this is tangent or so here you would say have a look. This is a very important concept, please. Now what do we have is this is the curve. The equation of the curve is y is equal to 2x square plus m into 2x plus 1. And the straight line is, where m is a constant, the equation of the line is y equals to 6x plus 4, right? Yes. We have a quadratic curve, y equals to 2x square plus m into 2x plus 1 and a straight line. Show that for all values of m, the line intersects the curve at two distinct points. So for intersection, we learned that b square minus 4ac must be always greater than 0. The questions in which you have to prove the identity or prove this b square minus 4ac greater than 0. So we will simply substitute it here. That is equal to 6x plus 4 is equal to 2x square plus m into 2x plus 1, right? And then we rearrange it, that be 2x square plus 2mx plus m minus 6x minus 4 equals to 0. So 2x square 2m minus 6 into x plus m minus 4 is equal to 0. Just have a look. We have not done any kind of mistake here. So this is a y equals to 2x square plus m 2x plus 1, and this is y equals to 6x plus 4, right? Sure. M for two distinct points, discriminant must be always be greater than 0. So now we substitute this y here, 6x plus 4, 2x square plus m 2x plus 1. 2x square plus 2mx plus m minus 6x minus 4 equals to 0. We rearrange it for x. So this is it. Now let's try for discriminant. So b square minus 4ac, that is equal to b square minus 4a and c. Like I'll just have to prove that this whole thing must always be greater than 0. Okay. So that is equal to 4m square minus 24m plus 36 minus 8m plus 64, right? And this is going to be 4m square minus, I guess, 34. 24 and 8 is 32m plus that is going to be 100. Can I take common? Yes, I can take 4 common, I guess. That is m square minus 8m plus 25, right? Acha, if I can express this thing as a complete square and make sure this is positive, then it's going to be like it's going to be always positive. So that is 4. Now let's try to write it as a complete square. So that would be m minus 4 whole square minus 4 square plus 25, right? That would be 4 into m minus 4 square minus 16 plus 25. That would be 4 into m minus 4 whole square plus 9. And even you multiply 4 inside the bracket, that would be 4 m minus 4 whole square plus 36. Now you would say this is always positive. Why? This is a complete square. It's positive. This is plus 36. So this is always positive. So if my gradient, if my discriminant is always positive, then it satisfied this thing that b square minus 4ac is greater than 0, then my line is going to intersect the curve at 2 points. Done? Yes. Is it clear, everyone?
Yes.
So this is a 5-mark question. Amit, is it clear, beta? Yes?
Sir.